Now that we've talked about for each, let's turn our attention to collect, which is one of the most common and useful terminal operations that are available in Java streams. Once again, we'll be looking at some examples that appear in my EX12 folder in my GitHub repository. And once again, we'll showcase the Hamlet program here. So collect is a terminal operation that typically returns a collection. It doesn't have to return a collection, but it usually returns a collection. And hopefully you know what a collection is. A collection in Java would be things like a list, which could be implemented as an array list or a linked list, a set, which could be implemented as a hash set, a map, which could be implemented as a hash map, and so on and so forth. So those are examples of Java collections that you undoubtedly have run across at some point. We certainly use them a lot in this class for the examples we do. We'll show a couple of different variants of collect in this particular lesson, all of which are shown in more detail in my EX12 folder. Once again, we're doing stuff with our good friend, the Hamlet example. And in this particular case, we're going to do things ever so slightly differently. We're going to create a list of characters. Again, not the characters that you would find like the character C, D, E, but instead the characters from Hamlet. And then we're going to go ahead and do some stuff to them, and we're going to collect the results into the appropriate kind of collection. And what collect does, collect has a very interesting role. It performs what's known as a mutable reduction on all the elements of the stream using some type of collector, like a list collector or a set collector or a map collector and so on, and it returns a single result. So you can basically think about a collector as performing reduction operations. So it could return things in various types of collections that we just talked about. It can also do things that do not come back in collections per se, but basically return objects that summarize elements according to various criteria. You can also have collectors that will return strings, for example. So they'll typically return objects that might or might not be collections, but they're basically doing something that returns a so-called reduced result. And you'll see what that means as we get into this. So let's start by taking a look at one of the simplest types of collectors, which is the list collector. And as the name suggests, what it'll do is it will take the results and collect them into a list, which under the hood is implemented as an array list, just FYI. But from the point of view of how we program this, it comes back as a list. Remember, that's always a good idea when programming with Java to use the most generic interface or superclass when you're dealing with subclasses that can have more concrete realizations. And that way you could change the implementation of the type of list without changing this code here. So we don't really care what toList returns as long as it's something that conforms to the list interface. It could be a linked list, an array list, some other kind of list if you wanted to make one of your own. But all we care about is using this as a list. And one of the key things to note with toList is what comes back. If there were duplicates in the stream, then you'll end up with duplicates in the results. So if we had, if you look at Hamlet, the play, Hamlet is two characters. There are two characters named Hamlet. There's two characters named Fortinbras, which is completely confusing when you first read the play when you're like, 14 or something like that in your English class, if you took an English class that studied William Shakespeare. That always confused the heck out of me for a long time. But the point is that a list is happily going to allow duplicates. Like stormtroopers, you can have multiple of the same thing. Collect is much less error-prone than that weird little idiom we used with for each. Remember with for each where we had the thing where we defined a list as a local variable. We had to make sure we initialized it by saying new array list. And then in for each, we passed in results : add. And we had to make sure we initialized stuff. And I told you that if you made it a parallel stream, chaos and insanity would break out. Big problems, right? Collect has none of those problems. So you don't have to allocate anything. The collector allocates the actual contents of the collection, in this case the list, that'll be returned from collect. So initialization is implicit, not explicit, so that takes off one more thing that can go wrong. And then secondly, it's also thread safe, which means if we were to stick in parallel here somewhere, if we were to say parallel stream instead of stream, then things would still continue to work properly without you having to do any other intervention whatsoever, which is nice. You can also have collectors that return other kinds of data structures besides lists. So here's the same program, except in this case, we're going to use set instead of list. So before we used list, now we're going to use set. And the main difference between a set and a list is a set cannot contain duplicates. So every element has to be unique. So unlike the stormtrooper example where you can have clones and duplicates, in this case you don't have any duplicates. So if there was multiple hamlets or multiple Fortinbrasses, there'd only be one left here. And in this particular case, hash set is the type of set that's created when you use the toSet factory method on the collector's utility class. Yes, sir? No, great question. So the question here is, what's the ordering characteristics? So obviously if you put sorted in there, it'll be sorted. But if we were to take sorted out there, then it has characteristics if the collector that you define has characteristics defined on it that are ordered. And we'll see when we get to collectors, and we probably won't get to them today. We'll definitely get to them next time if we don't get them today. Collectors can be given characteristics that say whether or not to define encounter order. If encounter order is defined, then you'll collect things in the order they were encountered, assuming they survive through the other transformations that take place. If you disable if you say, I don't care the order, then it's free to do it in whatever order it wants. Now, as we see when we get to collectors later, there may in fact be an order, even if you don't want one, just because it's easiest to do it in left to right order, in encounter order. But it's not guaranteed. And that would make that lack of a guarantee is more important in a parallel case than a sequential case. But that's a great question. So basically the question was, is in order preserved? And the answer is, it depends. You can also create other kinds of data structures such as maps. And this is very interesting as well. So what is a map? Just remember, a map is essentially going to be, well, let me rephrase that. A hash map is implemented with a hash table that has buckets that come off. And if you all remember your data structures course, when you hash something, you take the value that's given to you, or sorry, the key that's given to you, you hash it, which turns it into a value that's between typically 0 and some max size in the hash table. And then if things collide, they're resolved by chaining. And the way that a hash map works in Java is really cool in that it will adaptively change itself so that you'll have a list to begin with, and if the list gets very long, it'll adaptively modify itself to be a binary tree, a balanced binary tree, so that you end up with no worse than log n asymptotic time complexity for operations. That's just a little aside. So a hash map can be produced by using the toMap factory method on the collector's Java utility class. And in this case, we're going to take our characters, the names in Hamlet, and we're going to make a map. And the key will be the name of the character, like Horatio or Hamlet. And the value will be the length of the character in bytes, the character's name. So Hamlet would have 6, Horatio would have 7, and so on and so forth. And if you end up with multiple characters with the same name, in other words, you have duplicates, it's going to simply add the lengths together. So if you had Hamlet occurring twice, the length would be 12. That's just the way it works. So we can debate whether that's the right thing to do or not, but that's the way that duplicates are handled in Java maps by default, because they're essentially storing each key uniquely. So this will return a map, and you can see it maps strings to integers, where string is the name of the character, and integer, of course, is the length of the character's name in bytes. You can also specify what kind of map you want. So if you use toMap, it just uses a hash map. But if you want to use a more clever collector factor method, you can use groupingby. And groupingby will let you define what kind of map you want. So in this case, we're putting in tree map. So we're using identity, which is just the key. So the key will be the key. The map will be tree map. This is a constructor reference, by the way. Tree map : new is a constructor reference that makes a tree map. That's passed as a supplier, which is a Java functional interface that has a get method that, when called, will in this case return a new tree map. And then the last parameter here is something that's called the downstream collector. So let's see if I can explain each of these things in turn. So groupingby is a cool factory method that creates a given map, like a tree map, and it takes a first parameter which will partition the stream using a classifier function. In this case, it's just the identity function. It's just saying whatever the value is, use that as the key in the map. And I like to think about this role as kind of like the little desk organizer or organizer you use for silverware, where you put forks in one partition, spoons in another partition, knives in another partition, maybe different size forks in yet another partition, and so on and so forth. So as you can see in this particular case, we partition the input based on the identity of the key. Tree map is just the particular type of map we want to use, and you can read more about a tree map. It just basically implements a map as a balanced binary tree. So it has certain properties that are more desirable in some cases because it's always going to be ordered and it doesn't have to readjust itself the way that adaptively, the way that hash map will. And then the third parameter to grouping by is something called the downstream collector. And what that does is, after identity has been established, then the downstream collector is used to create the value that's associated with that particular key. And in this case, the downstream collector is going to sum up the lengths of the size of the key. So this is very much like what we had done before with this integer sum to the toMap factor method, which kind of hard codes things a bit more. And with grouping by, you can give what's called a downstream collector, which is actually a very powerful way of doing sort of arbitrarily complicated things to make your values whatever you need them to be. And we'll talk about some of that later. Yes, sir?
You had two keys.
At the end, yes. So what it'll do is, summing long is a downstream collector that will just, as you can see, sum up the lengths of the keys. And every time you find a duplicate, it'll just add that sum to the key, to the current value, which is the value of the key's size in bytes. Yes, that's correct. There's other ways to create streams. Here's a really interesting one. You can use regular expressions. So this is kind of a cool example where we're going to give the list of Hamlet characters as a single string of comma-separated character names. And we're going to create a regular expression pattern that will split on the comma. And so we say pattern compile, comma, that creates a regular expression. And then we say split as stream, and we give it a string, and it will use the regular expression to split this by the regular expression. So it'll split the string into a stream of strings, substrings, using comma as the splitting character. So that's a really super cool capability that was added in Java 8 and provides those capabilities in modern Java. And of course, you can collect things up into the tree map like we had looked at before. So that's the end of the overview of Java collect terminal operation. We will use collect quite a bit in this class. That's probably the most common way of doing things, and you'll get a chance to see how that gets used in the programming assignments you'll be doing.